So we're going to finish up section 0.2, which is all about functions, and we'll finish up by talking about composite functions and identity functions. And again, these functions are just so important because we're laying the groundwork. All of calculus is based on functions and whether functions are broken or curved or spiked or have cusps. So we're going to set the tone and make sure we really understand functions really well. So the first thing we want to talk about is, today, is what a composite function is. All right, so a composite is the function f of g of x. That's how you read these parentheses here, f of g of x. We make that by composing g and f in the order of g first, f second. All right, g first, f second. Sometimes you'll see it written as f with a little open circle here. F open circle g. You also read that f of g. And those two things are the same. That notation is just meaning that you are composing one function inside of the other. Okay, it's like taking your lunch and putting it, the pieces of your lunch, your fruit, your chips, your sandwich, your drink, and you take those pieces and you put them inside the paper bag or the lunch pail. Okay, we're taking one function and we're putting it inside the other function to carry it around. And so let's take a look at how that works practically. If you're going to take a function that is defined as a cube root here, so we have f of x defined as a cube root and g of x defined as a parabola. And if we're going to put one function inside of the other, how is that going to go? So for number 1, f of g of 1, that means f parentheses g parentheses 1. And so we're going to take g parentheses 1 and we're going to figure that out first. So take a look at g. I plug 1 into the function, so I'm going to plug in 1 squared plus 1, that's going to give me 2. So this problem becomes now f of 2. Then I'm going to take 2 and I'm going to plug it into the f function this time, and I'm going to put 2 here in place of x, and so I'm going to get the cube root of 2 minus 1, which is the cube root of 1, which is 1. And so the answer to number 1 is 1. F of g of 1. Let's look at number 2. Number 2 is g parentheses f parentheses negative 7. So this time I'm starting with the value of negative 7, and I'm going to plug that into the f function first. So I'm going to come here to the f function, and I'm going to plug negative 7 into that. That's going to give me the cube root of negative 7 minus 1, which is the cube root of negative 8. Now the cube root of negative 8 is a negative number. It's fine to have a cube root of a negative number, and the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 would make negative 8. So this becomes g of negative 2. So now I'll switch over to the g function, and I'm going to put negative 2 in here. Make sure you use parentheses when you square something, because negative 2 squared means negative 2 times itself. That should yield a positive number. So that's going to be 4 plus 1. So the answer to that is 5. Okay, let's keep going. Let's clean this up a little bit and give ourselves space to do questions 3 and 4. For number 3 now we're using a variable. We're not using an actual number. We're using a variable instead. And so for 3, we want f of g of x this time. So I'm going to replace g of x, it's not a number, I'm going to replace it with its actual equation. So f of x squared plus 1. That's what g of x is. So then I'm going to go to the f of x function, and I'm going to replace x with, not a number, but with x squared plus 1. So I'm going to end up with the cubed root of x squared plus 1 minus 1, which of course is just then the cube root of x squared. And another way to write that would be x squared, and then to show the cube root, you'll have divided by 3. So this composed function, the composite function, is x to the 2/3. Let's try number 4. G of f of x. So this time I'm starting with the f of x function. So that would become g of the cube root of x minus 1. So now I want to go to my g function, and instead of x, I'm going to replace that with the cube root of x minus 1. So that's going to look like the cube root of x minus 1 with a square around it plus 1. Another way to write that would be x minus 1, the square to show the square, and the over 3 to show the cubed root, and then a plus 1 on the outside. That would probably be the best way to write that answer. But either one would be acceptable. You wouldn't be marked down either way. You would be marked down if you tried to do something else, like saying that this minus 1 canceled out that plus 1. That would be totally illegal. You wouldn't want to do that at all. So I would just suggest leaving it like this. Okay, so those are some composite functions. Here's another way you might see a question like that. Find a formula for f of g of x, given that g of x is x squared and f of x is x minus 7, and then find f of g of 2. So first we want to find a formula. So we want f of g of x. That's going to be f of g of x is x minus, g of x is x squared. So then I want to go to my f of x equation, take out x, and replace it with x squared. So that would be x squared minus 7. So that is the formula for f of g of x. Then find f of g of 2. So f of g of 2 means start with 2 and plug it in here to the g function. That would be 2 squared is 4. Then take 4 and plug that into the f function, which will give you 4 minus 7, or 3. Okay, so first is finding a formula with the x, and the second is finding the value with the number 2. Now that we know about composing functions, we can use that to create what's called an identity function. So if you compose a function called f and its inverse called f inverse in either order, the result is what's called the identity function. So if you compose f with f inverse, or you compose f inverse with f, if the result is identical, if you get the same number or the same variable both times, then it is called the identity function, meaning that it is identical. Okay, if you get the same value or just the variable x both times, then it is the identity function. So let's try that. determine if these equations are inverses. So first they're asking us to do f of g. That means f of x squared. So I want to go to the f function, cross out x, and replace it with x squared. So that would be the square root of x squared. Or x squared for the square part over 2 to show the square root, which x to the 2 over 2 is x to the 1, which is x. So now let's try it the other direction. Now let's do g of f. So now I'm going to do g of the f function, which is x squared. So now I want to go to the g function. I want to cross out x and replace it with the square root of x. So that's going to give me the square root of x in parentheses squared, which again is x 2 over 2. So since I got the identical thing both times, I got x each time, these are inverse functions of each other. I just showed it or proved it by checking out the inverses, the composition, both times. So let's do the same thing with these two functions. 2x plus 3, 2x minus 3 are these inverses. So let's start with f of g of x, which is f of parentheses g of x, which is f of g of x, which is 2x minus 3. So I'm going to go to the f function, cross out x, and replace it with 2x minus 3. So that's going to give me 2 parentheses 2x minus 3 plus 3. I'll do a little distributing of the 2 on the outside. Oops. That will give me 4x minus 6 plus 3, or 4x minus 3. Now let's check the other one, g of f of x. That means g parentheses f of x. That means g parentheses 2x plus 3. So then I want to go to the g function, cross out x, and put in 2x plus 3. That's going to give me 2 parentheses 2x plus 3 with a minus 3. I'll do some distributing again. That gives me 4x plus 6 minus 3, which is 4x plus 3. I do not get the identical thing. Therefore, f and g are not inverses of each other because their compositions did not yield the identity function. So you're checking inverses. Okay, one way to check inverses is on a graph. Does it pass the HLT and the VLT? Okay, another way to check inverses is to use composition to see if you get the identity function. And when you don't, then you know it's not an inverse. And that finishes up lesson 0.2. So when you finish up 0.2D as for homework, then on Friday you'll work on the worksheet, which used to be the quiz. So it's important enough that I think that it should be on there. And then I'll check your answers to that when you submit it. So you check your answers, please, to 0.2D for homework, and then I will check your answers to the worksheet when you submit it. I hope you have a great weekend. I hope you stay cool and relaxed, and that you're able to carve out some time for fun. And then I'm looking forward to spending some time with you again next week.